Section 1, sequences. Several of the things we're going to talk about in this section you may remember from Algebra 2. So hopefully you learned some things well in Algebra 2, and you can use that information on this section. Infinite sequence. I think you know what infinite means. When we talk about sequences, we talk about an ordered set of numbers. I might have a set that is doing this. I bet you could recognize what would be the next number in that sequence. 10, 12, 14, etc. My dots at the end mean it keeps going forever, an infinite sequence. They say an infinite sequence is a function whose domain are the positive integers. What that means is when I use 1, that's my first positive integer, then I get this first answer. So this might be looked at as f of 1, the function when I use 1, whatever my function is that generates these numbers. And then f of 2 would be my next number, which is 4. And f of 3 would be my next number. And f of 4 would be my next number, etc. That's what they mean when they say the domain is a set of positive integers. We have a first one, a second one, a third one, a fourth one, a term, and whose range is a set of real numbers. So any real number can be an answer. That comes out of it. An example, they say, let the function to generate our values be this one, 2n minus 1. So f of 1, the first number I put in is always going to be 1. 2 times 1 is 2, minus 1 is 1. There's my answer. F of 2, etc. You put it in. And we can keep going forever. So all those values in the range make up the terms of the sequence. So these are all the terms of the sequence, the values in the sequence. That is the expression that keeps giving me the values of the sequence. First term is 1, second term is 3, third term is 5, etc. We often will refer to the nth term. The nth term is the term where n is whatever number we want it to be. Like the 27th term, well, n is 27 then. And so we can figure out the 27th term by putting a 27 where the n is. That's what we mean when we say the nth term. General expression, or the general term, 2n minus 1, general term is going to be the equation that gives us our answers, our terms, our numbers that make up the sequence. So let's try a few different general expressions and create some sequence. It says find the first 3 terms of the sequence where a sub n, so we often use the letter a to stand for one of my terms. A sub 1 would be the first term, a sub 2 the second term, etc. So a sub n, the general expression of the equation, is this thing here, 1 divided by n times n plus 1. So if we did that, if I wanted to find a sub 1, I'm just substituting a 1 where my n is. And see if you can't give me that answer. What is the first term when you're all done with that? 1/2. On the bottom, we have 1 times 2, which is 2, 1 over 2, 1/2. That is going to be our first term. Their second term, a sub 2, we will call it. We're putting a 2 where the n is. Whoa, it's supposed to be a 2. What do you get? 1/6. And then a sub 3, we'll do it without me writing it down. Just stick a 3 where the n is. 1/12. So there are the first 3 terms of that sequence. Find the 8th term of this sequence right here. So if I want the 8th term, I'm looking for a sub 8. In other words, my n value is 8. So 2 to the n power becomes 2 to the 8th. Your calculators may be useful, we'll see. And n squared becomes 8 squared. Well, I'll do that part, 64.
256.
2 to the 8th is 256? Is that what you're telling me? So how does that reduce? Does it go unevenly? 4. There you go. The 8th term of that one happens to be 4. So if they give us a general expression or a formula, an equation, we can figure out what any term is in our sequence. Recursively defined sequence. Recursively comes from the root word reoccurs or recurs. So what does that mean? Let me come back to this notation. A sub n, if n is 3, That means I'm looking for the third term, a sub 3. So if I'm looking for a sub n minus 1 when n is 3, that would give me a sub what when I'm done? 2, because 3 minus 1 is 2. Now I want you to understand the general meaning of a sub n minus 1. It means the term 1 previous to the nth term. If I started out with n being 3, then a sub n minus 1 is a sub 2, the term 1 previous. So what do you think the expression a sub n minus 2 means, just using words? 2 previous, the term that is 2 before the one we are talking about. So keep that in mind, because we use expressions like a sub n minus 1 or maybe a sub n minus 2 in recursively defined sequences. So if they say a sub 1 is 1, the first term is 1, a sub 2 is 1, the second term is 1, and a sub n plus 1, what do you think a sub n plus 1 means in words? Think back to that. The next one, the next term, 1 greater. A sub n minus 1 is 1 previous, n minus 2 is 2 previous, then n plus 1 is 1 succeeding, after, 1 after. So the next term is what this really says, a sub n plus 1, is found by the previous term plus the term I'm on. So if I want to find a sub 3, well, I get the 1 previous plus the one I'm on. Ooh, that's a little bit of a bad description. So a sub 1 plus a sub 2. These would be 2 previous terms to a sub n minus 1, n plus 1. A sub n, and then the next term would be a sub n plus 1 if I was writing them in order. Let me write these in order for a minute. Let me do a sub n right here in the middle. The next term would be a sub n plus 1. The term right before it would be a sub n minus 1. So if you can kind of get the general idea of what these notations mean. So when I'm looking for a sub n plus 1, when I'm looking for this term, I take 2 previous, in this case, plus the 1 previous. I take this one plus this one. That's what it says right there, how I get the next expression. So if I want the third term, I'm going to need to take, if I want the third term, I need to take my second term plus my first term. And I add those together and I get 2. And then if I want to get my next term, I'm going to take the 2 before it. So the 2 before it are 1 and 2. And that gives me 3. Then if I want my next term, I take the 2 before it, which are 2 and 3. And if these were all in line, it would be a little easier to see. 1, 1, the next one is 2. The next answer is 3. The next answer is 5. Now let's take it. 1 and 1 make 2. 1 and 2 make 3. 2 and 3 make 5. So 3 and 5 make 8. The next number would be 13. 5 and 8 make 13, etc. So there's a notation right up here that we can now interpret and generate a sequence from it. This one that they have generated right here is actually a very, very famous sequence. It's called the Fibonacci. So if you're Italian, the Fibonacci sequence, some of you maybe have heard that. The Fibonacci sequence is supposed to be a sequence that occurs commonly in nature. If you take a flower like a daisy, and it has all these petals around the outside of it, maybe you've heard of that thing, you can say, oh, I wonder if that person really likes me or not. So you start picking the petals off. Well, the Fibonacci sequence is supposed to be a set of numbers that will be how many petals will be around it. In other words, one of those numbers, if you counted all the petals in your daisy, it should be one of the Fibonacci numbers. It's not always, but generally it is. Or other things that are like that, like pine cones that have all those little, they're really called petals, but kind of little spiky things that come around the outside of a pine cone. If you count any row around, generally it's going to fit on a Fibonacci sequence. So the Fibonacci sequence is famous mathematically for many things, but one of the things is it's a common number that's supposed to show up in nature. You can look up the Fibonacci sequence and learn more about it. All right, let's try it out here. Let a sub 1 be 1, and a sub n, in order to get any term, we are going to take n times a sub n minus 1. Well, let's see what that means. We're supposed to find the second, third, and fourth terms. So let's see if we can get the second term here. All right, to get any term, I take n. What is n when I'm finding the second term? Don't make it harder than it is. 2. N is 2. N is 2. Times a sub n minus 1. So I need to multiply this by, what does a sub n minus 1 stand for? 0. The one before. What's the term before this a sub 2? It's a sub 1, which was 1. So in this case, it's 2 times 1, which is 2. Let's try a sub 3. I'm using this formula right here. What is n now? 3, third term. Times the previous term. What's my previous term now? 2. 3 times 2 is 6. So if I want my fourth term, it's going to be, tell me the numbers. 4 times 6, 24. There are the first, or the second, third, and fourth terms in that sequence. And it has been defined recursively. When they say defined recursively, it's going to have one of these things in it. A previous term in some way is going to be used in it. Your book didn't say, but this is called defining it explicitly when you have a specific equation that gives you the terms that doesn't use previous terms in it. Those are called explicit definitions, and the previous one, the one we just saw, was a recursive definition. All right, factorial. We use factorial a lot in different branches of mathematics, and it looks like an exclamation sign that is really said in factorial. We're not excited about that n, though of course we are excited about that n that's sitting there. But it means in factorial. Now find in your calculator, let's not find in your calculators yet, but you are going to want to find your factorial button. I'll tell you where to look. Here's the definition. We need to know what it means. In factorial means I'm going to start with that number, so let's say it's 4 factorial. I start with the number 4, and I'm going to multiply it times that number minus 1. Well, what's 4 minus 1? 3. And I'm going to keep doing that pattern until I end up with 3, 2, 1, or however many the numbers happen to be. So it's one number less that I keep multiplying by. So 4 times 3 times 2 times 1, and I stop when I get down to 1. So 4 factorial should be the number. Do that math. What should you get? 24. Now, go looking in your calculators, and several of you will find this button. It stands for probability, PRB. And who knows why that bell was ringing then. Hit the PRB button, and for a lot of you, you will then see a menu across the top that you can start arrowing over until you find the factorial. Now, the problem was I should have told you to hit 4 first. You have to first, so clear out of that. You have to first hit the number you want to take factorial of. Then if you go to your PRB menu, you can arrow over and find the factorial, enter that, and hit equals, and you should get 24 if you have done it correctly. All right, so they give you some examples. There's 5 factorial, it's 120, 20, 10 factorial is that big number, 12 factorial is really, really big. In general, in factorial is always the number times one less than that number factorial. 12 factorial is 12 times 11 factorial. You can say that for anything. At any point in a factorial sequence, you could stop and say that number factorial. In other words, 10 times 9 times 8 times, I could say, 7 factorial. That would take care of the rest of it. What's the purpose in that idea? Well, let's do some simplification by hand of some of these things. Evaluate this. So if I look at 8 factorial over 5 factorial, well, I know 8 factorial is 8 times 7 times 6 times 5. I'm going to stop there and call it factorial. Why did I stop there? Because that's the number I have on the bottom. And those things are equal to each other, so they are gone. So all I have left is 8 times 7 times 6. Try that by hand on your calculator or by head in your brain. 8 times 7 times 6. What do you get?
Sweet.
Say that again. Thank you. 336. That should be the same answer as if you went and did 8 factorial divided by 5 factorial. So let's try part B and see how it can be simplified. If I have 6 factorial minus 4 factorial, well, I'm going to go 6 times 5 times 4 factorial minus 4 factorial. Those are common. I can factor out a 4 factorial, and here I just have 6 times 5 minus, shouldn't have put parentheses there, 6 times 5 minus 1. I factored out a 4 factorial from each of these terms. Well, what's 6 times 5? 30. 30 minus 1 is 30 minus 1 is 29. So what I really have is 4 factorial times 29. Now, with calculators, generally we would go ahead and just use the factorial button. But you can simplify it this way. What's your answer? 636? 696. If we have a sequence, then we often can figure out a formula that goes with it. And we can then get what is the sum of the terms as long as we stop at some point. It's called a partial sum. So if I just have one term using this, n would be 1 to start with. So this is 1 over 2 to the first. That's how they got 1 over 2. Well, the sum of just one term would just be 1/2. The sum of 2 terms, well, the first one is 1/2, the next term is 1/4. I added it together, we got 3/4. The sum of 3 terms, that's what they're showing here. We can get what are called partial sums, a sum of part of the sequence. And so here they happen to have the first 4 terms. That would be the answer. Now, how about this one where they say plus ... 1 over 2 to the n? How many terms do I have? How can I get that partial sum? Well, we have a notation for that. This would be called the nth partial sum. This is the 4th partial sum because I did 4 terms. Here's the nth partial sum because we're doing n terms. N can be whatever we choose it to be. And when we take the sum of a sequence, it's called a sum of a series. It's called a sequence of partial sums. A series is the list of numbers. A sequence is when we find their sum, when we add them up. And we have summation notation using the Greek letter sigma. It means we are finding the sum of all these numbers in the series. And here's the notation. So let's read this thing. We have the summation of a sub I. Now, a sub I means a sub 1, our first term, our second term, our third term. Sometimes there'll be a formula that goes there. From I equals 1, that is the lower limit, to n. That is the upper limit. That's where we stop. So we start where I equals 1, in this case, a sub 1, the first term. And we'll stop at whatever n is. They'll give us a number. Maybe it's 3 or 4 or 17, something like that. So we can have and the letter is called the index of summation. The letter, the variable we use in this equation. Let's try it out down here. They say this is what an nth term looks like. Evaluate the summation of a sub I from I equals 1 to 4. That means I want to find a sub 1, the first term, plus a sub 2. I'm starting with I equals 1, so it's first a sub 1, then it's a sub 2, and I go all the way until I get to 4. That's where I stop. So that's what they're asking us to do. Find the sum of the first 4 terms from 1 to 4. And this is how I get the terms. So I start with n being 1. A sub 1, n is 1. 1 over 1 plus 1. Plus, then I go to 2. 2 over 2 plus 1. Then it's 3 over 3 plus 1. Then it's 4 over 4 plus 1. And then we try to get the answer to this. 1/2 plus, help me out, what are these fractions? 2/3 plus 3/4 plus 4/5. That's what we're trying to add together. You have calculators? That'll help us save a little time on common denominators. Why don't you add those fractions together for me? 1/2, 2/3, 3/4, 4/5. What? That can be done in your head. Take you a little while to think about your common denominators.
Like,
any answers?
163 over 60.
163 over 60?
Yeah.
163 over 60. 163 over 60. You are going to get some answers that are like this. There is the sum of that series. Part B. They want us to find the summation from j equals 2 to 5 of a sub j. So we are going to find a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. That is what they are meaning. We're starting with 2. And how do I get these a sub n terms? Well, this is how I get it. So to get this second term, I need to take -1 and square it, and then multiply it by 2 squared, plus. Now I'm getting my third term, and I'm just using this thing here. I have a -1 that has to be cubed, and then it's times 3 squared. Then my fourth term, -1 to the fourth, and then it's 4 squared. And then it's -1 to the, fifth, and it's 5 squared. Just substituting my different n numbers into this formula here. We can do this in our head. If I square a -1, I just get the number 1. So 2 squared, that's 4. This is going to be a -1 times 9, so -9. And that'll just be 1. 4 squared, that's 16. And that's going to be a -1, 25. -25. So what do we have here? We have 20 if I put my positives together. Minus 34. -14. All right? So we can generate a series, a sum of that sequence from this summation notation. So now we know how to read that summation notation. There's some properties of series that can be useful. And here they have listed 3 properties. If I have the summation of the either sum or difference of 2 terms, you can individually find the summation of the first term and then either add or subtract, depending what it is, the summation of the second term. So that's the first property. So I can rewrite it either way. Second property, if I have a constant, c is a constant, c is some real number, times a sequence, I can just take the summation and then multiply it by the constant, and instead of having to multiply by the constant each time. And the last one, if I have the summation of a constant from 1 to n, let me show you number 3 for just a minute. Let's say they want the summation from I equals 1 to 5 of the number 6. What are they meaning? Well, if I wrote this out, I would take my first term is 6, plus my second term is 6. My third term is 6, because there's no n or there's no I to change the 6. It's just 6 each time. And I go all the way to 5 terms. Well, if I have 1, 2, 3, 4, 5 terms, that's just the same thing as taking 5 times 6. That's what they are saying there, n times c. That's all that is saying on that last one. So those are 3 properties that sometimes can be used. And I think I am done, and it is your time to work on your syllabus.